Hello everyone, this is Dr.K. Kavita, working as Associate Professor in the Department of Mathematics in BVR Hyderabad College of Engineering. So today we are going to see that the rank methods and rank rank of the matrix. You can see that here shortly because many definitions will be there here. Uh, so first one, it is the largest order of any non-vanishing minor of the matrix, or we can say that it is the order of the highest order non-zero determinant of the matrix, or it is the maximum number of linearly independent rows and columns of a matrix. We can see that the third one. And briefly, we can say that non-negative integer R is said to be the rank of the matrix if it possesses the following properties. There is at least one minor of order which is non-zero. Every minor of order greater than the R is 0 and it is denoted with a row A or R. So this is the definition of matrix rank, and we can see that the rank methods are three types by using echelon form, by using normal form. So moving on to that first one, rank of a matrix by using determinant, we can see that we are aware of that many methods, but I'm going to show you a very short method. This is also a important one. Now you can see that here, using here generally this is the rank, matrix given, and we are going to add that one of the column 0, 0, 0, and it becomes to 3 by 4. Now you can see that the A1, like the red column only, we are going to add that, and A1 equals to 0. And then next, moving on to A2, this A2, we can see that here, sorry, A2, we are going to get that this. And A3, we are going to get this like this. And A4, 1, 4, 3, 6, 9, and this 0. And we are going to get like this. So here we observed that all are zeros. So we can't say that row A is not equals to 3. That means we are going to moving on to 2 by 2 matrix. Same the thing. Now the submatrices we have taken 3060, which is A5, and one more submatrix. Whatever the thing you can take that, but 2 by 2 especially concentrate. And these selection of the elements also will be like that. And if you concentrate like a 1, 2, 4, 5, which is not equals to 0, then we can say that the rank of the matrix equals to 2. Therefore, row A equals to 2. Next, moving on to the elementary operations, or we can say elementary transformations. There are two ways are there: elementary row transformations and elementary column transformations. Right now, elementary transformations, row and column, you can see you can interchange any two rows, multiplication of any row by non-zero scalar, add multiple of one row to another. Next, similarly, elementary row operations, we can check it out using I'm going to show that like this. If you change R1 to R3, we'll get like this. Multiplication of non-scalar will be getting like this. Okay. Next, add a multiple of one row to another. You get like this. We can add, we can delete like that. Next, rank of a matrix using echelon form by taking, so first we can see that what is echelon form. So echelon is the military term that refers to specific type of a formation of a troops or ships or aeroplanes like this, okay? So this is the left-handed echelon formation, and this is the right-handed formation of echelon form like this, okay? What is the position formation? Okay, it may be a left or right. Now, echelon form of a matrix can be defined like this. A matrix is said to be echelon form if rows, if any exist, they should be below the non-zero row. The first non-zero entry in each non-zero row is equals to 1 or unity. The number of non-zero zeros before the first non-zero element in a row is less than the number of such zeros in the next row. So it is looking like this. And finally, when we can say that rank of the matrix, rank equals to number of non-zero rows there in a echelon form. So this is the formation. We can see that formation, 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 right? So this is the left-handed echelon form. We can see that this is the example we can see here. This is the matrix from the data we got to find that this matrix, which is a 4 by 4 matrix. We have written that A, and the below. See, first you have to identify that these pivot elements, and then this element becomes to zero. This element becomes to zero. This element becomes to zero. Further, we are using that elementary transformations like R2 minus 2 R1, R3 minus 3 R1, R4 minus 2 6 R1. We are going to get that this is the resultant matrix. After that, concentrate on the second, fix that A22 and converting into this element 0, this element 0. Now we are going to get that R2 interchange to R3 because we can't make that taking into conversion because 82 you have to fix. So that's the reason interchanges of that even R4, then after that R4 minus R2, then it becomes to both on zeros, right? And the last, these two looking like the same rows, no? So then R4 minus R3 also getting into zero. So we can observe that this is in the form of upper triangular form. No need to make that any other operations. The above equivalent form is an upper triangular form. So the rank of the matrix equals to how many rows are there? 1, 2, 3, 3, 3. Number of non-zero rows in the echelon form equals to 3. Number of zero rows is 1. So how many number of non-zero rows are equals to rank of the matrix? That equals to 3. The formation will be here 3. Left-handed echelon form. So thank you so much. We can see that in the next video. Thank you.